off with a little, I guess it's kind of a story. I don't know. You don't need to write anything down. Just pay attention to me for a second here. I want you to imagine that you got a ball, and that ball is 1 foot in diameter. So from one edge to the other, 1 foot. How big would that be? How big is it? 1 foot. 1 foot. Let's see how good we are at judging distances. That looks a little too big. Yeah, what's kind of like 1 foot would be 12 inches. Yeah, kind of like that big. Most standard pieces of paper are 11.5 inches. So a standard piece of paper is 11.5 inches long. So it'd be just a little bit bigger than this. Okay, so I want you to imagine you got that ball. In fact, imagine you've got it sitting on the desk in front of you. Put your hand on top. Your hand should be about 1 foot off of the desk. You guys hear me? Okay. When I snap my fingers, that ball is going to grow and it's going to get twice as big. Okay. You ready? Go. So now it's twice as big. It's up here. That's a little too tall. We're looking for about 2 feet. Okay. We'll get there. Don't worry. All right. Now I'm going to snap my fingers again, and that ball is going to get twice as big again. So look at where you're at right now. After I snap my fingers, your hand better be twice as far above the desk. You ready? Go. Whoa. Okay. All right. We're going to move it down to the floor now. Move it down to the floor. Same distance above the floor. Right. We're about 4 feet off the floor. That's perfect. Right there. Okay. I'm going to snap my fingers again, and it's going to double in size again. Please stop. I'm going to snap my fingers, and it's going to double in size again. Okay. Now where are we at? We're like 8 feet, right? Now we're running out of space here. If I were to snap my fingers again, we're going to go pretty much up to the roof. Right kind of in the middle here, I think it's about 16 feet. Now, can you guys remember how many times did I snap my fingers? So we started with 1 foot, and then I snapped my finger once, and we were at 2 feet. And then we did a second time, and we were at 4 feet. And then we went down to the floor, and then I snapped it a third time. We were at 8 feet. 4 times got us to 16 feet, right? Okay. All right. I want you guys to think of the biggest thing you can think of. What is the biggest thing that you can think of? A building in Paris? That's pretty big. I can think of something bigger. What else? Huh? The sun. The sun is huge. You guys know how many Earths can fit inside the sun? It's like thousands, isn't it? The sun's pretty big. Can you think of anything bigger than the sun? Black holes. There's some black holes that are way bigger than the sun. So yeah, what's bigger than that? The solar system, the nebula. You're talking like galaxy size now, right? Those are pretty huge. What's bigger than a galaxy? Universe. Doesn't really get any bigger than the universe, does it? Well, I mean, we don't know. We don't know what's beyond the edge there. You can't see past the edge of the universe. Actually, we don't even know if there is an edge of the universe, but there's a certain amount that we can see. And the amount that we can see is pretty big. So here's my question to you. I want you to go back to that 1 foot ball that's on your table. How many times do you think I'd have to snap my fingers before that ball was the size of the universe? Give me a number. 18,460. That's very specific. I love that. Thank you. Any other guesses? 18,000. You watch the Price is Right. We're calling more than what he said. What else? Any other guesses? Come on, give me a better guess. Not a better guess, a different guess. That was perfectly fine. We're stuck on this 18,000. All right, so I think this blew my mind when I learned this. Okay, 91 is the answer. 91 times. If you started with a ball 1 foot in diameter, you doubled it 1 time, 2 times, 3 times, 4 times, 5 times, all the way up to 91 times, it would be as big as the whole universe. Isn't that crazy? Pretty close, yeah. All right, and this actually works going backwards too. So if you take that ball and you cut it in half, and you cut it in half, and you cut it in half, it's going to get smaller and smaller, right? What's the smallest thing that we can observe in science? These are all in science class. Atoms. What's the smallest atom? What is number one on the periodic table of elements? Close. Helium is number two. Hydrogen is number one. A hydrogen atom. Okay, so if you took a 1 foot ball and you cut it in half each time I snapped, I'd only need to snap 31 times to get it down to the size of a hydrogen atom. So this is crazy, guys. This is the truly nutso thing. Hey, don't miss this. Okay, if I took a hydrogen atom, something that is so ridiculously small that you can't even imagine how small it is. If I took a hydrogen atom and I snapped my fingers and I made it double in size every time I snapped my fingers, let's say I snapped my fingers once a second, it would take me about 2 minutes before it was the size of the universe. Well, you only have to double a hydrogen atom 122 times before it was the size of the entire universe. I think this is math, right? Because it's all about multiplying by 2. But we're doing it over and over and over again. So exponential. So one of the powers of exponential is it kind of allows us to kind of get an idea of how big things are and how small things can be. In order for us to really use them, we need to learn the properties. The other big thing, guys, that I'll use to try and motivate you to be interested in this unit is the stuff that we're going to learn about exponents here is going to set us up for exponential functions in the second semester. And that unit is all about money. The people in this world who understand how exponential functions work are the people who understand how money works, right? Things like interest and investments and taxes and all that kind of stuff. So right now we're going to be doing some really mathy stuff, but the reason we're doing this is so we can understand some bigger picture stuff going forward. So we're going to switch over to our notes, please. If you've got a notebook or you've got a binder you can keep your notes in, then I want you to put that in there. I'm not going to do this in the packet. We will add some of this to the packet later, but our work today is going to just go onto separate paper. So if you could switch over to that and let's get our notes started. This is 3.1.1. And we're going to be working on page 95. You've got a book at your table. Can someone at the table please get that book open at page 95? Can you do me a favor and stick a calculator or something in there because these books tend to close themselves. If anybody needs paper, remember I've got lots of paper over in the drawer over there. You're going to need some paper today. Page 95, 3.1.1. We're talking exponents today. So our goal is going to be to simplify expressions with exponents. So we're going to start with problem 1. It says 3-1 in your book because it is the first problem in chapter 3. And problem 1A, got it right in your book already up here. Problem 5 is 5. And the instructions say to expand it. They want you to write out what is y to the 7th mean. Well, that means we're going to make a bunch of copies of y. How many copies of y are we going to make? 7 y's, we're just going to stick to multiplication. So write it out 1, 2, 3, 4, 5, 6, 7. Let's get some multiplication sign in between, and that's it. So that's what to do there. I'm going to make us do this with like y to the 53rd or something. Let's see what they ask us to do next for part B. We've got 5 and then parentheses 2 down. All right, so this one's a little bit trickier. We've got to ask ourselves, what's the thing that's going to get copied over and over again? We're going to make 3 copies of something. We're going to make 3 copies of 2m. You're absolutely right. The exponent is on this parenthesis here, so we're going to make 3 copies of that. Now the 5 doesn't have an exponent on it, so there's just going to be the 5. Actually, I'll give you a little secret hint here. The 5 does have an exponent on it. We just don't have it written. Anybody know what the exponent on anything that's not written? So 1, yeah. There's 1 copy of 5 and 3 copies of 2m. So let's write that down. Here's my 5. And I'm going to have 2m, 2m, 2m. And all those things are going to be multiplied together. Right? Can I get you guys to try part C for me, please? I'll write it up here. It's x to the 3rd just a second. Ooh, this one's going to be a little tricky. Give that a shot. I'm curious to see how you guys tackle this one. You're like, speaks dominantly. I'm curious, did anybody think of this as it was going to be 2 copies of x to the 3rd? Anybody write it like this? Nobody did it that way. Is that right? Yeah, totally right. This says make 2 copies of the thing inside the parenthesis, and that was x to the 3rd. Did anybody do it like this? Did anybody say that this is 3 copies of x? But I gotta make 2 copies of those 3 copies? Anybody do it that way? A couple people did it that way. What other ways did you guys tackle it? 3x times, did you x to the 3rd times x to the 3rd, you mean? Because 3x is different from x to the 3rd. Yeah, so x to the 3rd times x to the 3rd. Yeah, absolutely. Absolutely. No matter how you did it, though, how many x's are we going to end up multiplying together? There's going to be 6, aren't there? There's going to be 6. There's 3 copies here times another 3 copies here. That's 6 altogether. I want you to write one final step here. This is going to be x to the 6th. We've actually done 2 things here. We've expanded, and what we just did right here is called simplifying. Oh, I have one last expand one. Yes, question. So let's keep questions. Okay. I appreciate the compliments. I'll tell you honestly. I'll give you the honest answer. All right, let's just expand this one. Now, super common mistake happens here. If you make this mistake, I'm going to say congratulations on getting it out of the way early. We know we're going to make 5 copies of something. We know we're going to make 2 copies of something. And it's pretty clear that we're going to make 2 copies of 1. Agreed? The big question is, and the easy mistake here is, what are we making 5 copies of? The x or the 4x? Who thinks it's just the x? Anybody think it's just the x? Who thinks it's the 4 and the x? Be brave, be brave. Yes, congratulations. That's wrong, but you made the mistake, and now you're never going to make it again, right? You learned from it today, and you never make it again. So check it out. If they wanted us to do the 4 and the x, they would have put the 4 and the x in parentheses with that 5 on the outside. Okay, this 4 actually has its own exponent. What is the exponent on this 4? This 4 has its own exponent of 1. So there's only going to be 1 copy of the 4. When you started this problem, if you were thinking there are going to be 5 copies of that 4, that's not right. But that's okay. You made that mistake, learn from it, and then you don't have to make it again. So there's going to be 1 copy of the 4. 5 copies of x, and then 2 copies. All right. We're going to do part of question 2 together. I'm going to walk you through a couple of these. Now, what we're going to do here is we're going to expand and we're going to simplify it. So we're going to do part B. We're going to go and skip part A. And in part B, they've got 8 parts here. They're giving us Roman numerals. These are fun. So let's write down what it says in the book. It says x times x times x over x. Have you guys ever learned about canceling in fractions? Can you put your phone away? Go ahead and put it in your bag. Thank you. You guys ever learned about canceling in fractions? Did you know if you have the same factor in the top and the bottom of a fraction that you can cancel them out? You're aware of this? So like this x here could cancel with x down there. And they're just gone. That's a legal move in math. So when we do that, how many x's do we have left? 2 x's. So we're going to write x to the second. And that's going to go on the top of the fraction. Is there anything left on the bottom of the fraction? No, but there is something there. There is something there. What is the invisible thing that we can always put on the bottom of the fraction? 1. That's x to the squared over 1, or I would just say x to the second power. All right, let's try this with I, otherwise known as Roman numeral 2. I says they want us to do x to the fifth over x to the second. We're going to start by expanding. We're going to write out what is x to the fifth and what is x to the second. And I'm going to stop putting dots in between and just write the variables next to each other. It saves a little bit of time. 1, 2, 3, 4, 5 x's on the top, 1, 2 on the bottom. Can we do any canceling here? Yup. How many x's left over? 3. That's to the third. We're going to do one more together, then I'm going to ask you to do the next 4 on your own. So pay attention here. Actually, the next 6 on your own. I, otherwise known as Roman numeral 3. This one is asking us to do x to the second times x to the third. We're going to write it out, and then we're going to simplify it. Does anybody want to take a guess what the simplified answer is going to be before we write it out? How many x's do you think we're going to end up writing out altogether? 6. Okay, good guess. Any other guesses? 5. Good guess. Any other guesses? Well, let's write it out. This says make 2 copies of x, 1, 2, times this says make 3 copies of x, 1, 2, 3. And in the end, how many copies of x did we end up with? Right. And I don't want you using shortcuts today. I want you to write out the stuff in between, but you can go ahead and start thinking about what the shortcuts might be, because when we come back together on Friday, we're going to focus on shortcuts. Can I get you guys to do the rest of the problems in part B there? All right, so that means you're going to do 1, 2, 3, 4, 5, 6 more problems. The challenging one is very challenging. When you get to the challenge, I want you to try and see what you can do with that. I'll give you about 5 minutes to work on them. Come back together and check answers in a minute here. So please check over your answers. My answer is the last one over here. And I apologize. I flipped the last couple over. If you didn't get the right answer, go ahead and put a star next to it, or raise your hand and ask a question. That is entirely possible I've made a mistake here, so if you think I might have, please let me know. Don't ask me a question about this. Do this either. What if the A comes? What's a good? So let's look at the. So are we okay with writing out 3 copies of W on the top and 2 on the bottom? So you guys are okay with that? And you canceled and you ended up with just 1 W left on the top. So then when we do this, if we ever see a fraction that has numbers in it, even if there's other stuff, we want to look at those numbers. And I've got 16 and 2. Let's simplify that. What is 16 divided by 2? 8. That's where the 8 came from. Another way to think of this would be, what number can I divide into 16 and 2? What number divides into both 16 and 2? We can divide them both by 2. If we did that, we would end up with 8 over 1. So it would look like this. 8W over 1, which is the same as just 8W. Thank you for asking about that. Does anybody have any other questions? So like, the very first one? Yeah, so the very first one, we had 3 X's on the top, 1 X on the bottom, and we canceled. So we just had 2 X's on the top, nothing left on the bottom, but really there was a 1 down there. Okay. Final answer was X to the second. Was anybody able to get this challenge from? Was anybody able to figure out that 35? Who was able to figure out that there's going to be an exponent of 35 on the challenge? How do you think I got that 35? The original problem had a 50 on the top and 15 on the bottom. I subtracted them, right? And we're going to learn some shortcuts on Friday. We're going to learn that when we're dividing, and we end up subtracting our exponents. If you imagine if I wrote out 50 X's, 15 on the bottom, I would end up crossing 15 of those 50 on the top out, right? Coming in, we're going to have left side of 35 left. Okay. One last thing I need you guys to do for me today, and then you are free to start on the assignments. On the next page, flip your page over to page 96. We've got 12 problems here. And I want you to work through these. Now, I want to do a couple of these together because I don't want you to have to write out as many things as you might have to write out. So can I get you guys to do a couple of these together, and then I'll have you come back and finish the rest. We're going to do D together right now. This is number 3, part D. When you get to this in your own work, you'll be able to skip it if you do it with me right now. The original problem was x to the 10th times x to the 12th. I do not want to write out 10 copies of x's and 12 copies of x. I just don't feel like it. And I don't feel like we really need to. Because if I were to write out 10 copies of x and another 12 copies of x, I know how many x's I'm going to end up with, right? How many x's would that be altogether? If I had 10 and then another 12, that would be 22 copies of x. Can we just go ahead and skip to the answer without having to write all those out? Are you guys comfortable with doing that? Let's do that, please, so we don't have to write out 22 x's. Let's have a look at H. I didn't do any timesing and dividing. I pictured in my head I had 10 x's and another 12 x's. Altogether, I'd add up all the x's, I get 22. Yep. Let's look at H together. We got 10 m to the 30th power over 2. Oh, I didn't put it right up. M's take forever too. They're like the longest letter to write out, aside from W's. So forget about the 10 and the 2 for right now. Focus on the M's. If I wrote out 30 M's up here and then another 8 down here, and I started crossing them out, I'm going to have leftover M's. Where are my leftover M's going to be? On the top or the bottom? They'll be on the top. How many will be left over after I cross out 8 of them from the top and the bottom? Would be 22 of them left up here. Agreed? 30 minus 8 is 22. Yes, so M to the 22. Now, think through the 10 and the 2 with me. What can I divide both 10 and 2 by? Divide them both by 2, and let's simplify that fraction. 10 divided by 2 is 5. 2 divided by 2 is 1. I will probably write my final answer as just 5 to the 22. We don't really need that one on the bottom there. We're gonna do one more together, and then I'm gonna turn you guys loose on finishing the rest of these. K. Look at K with me, please, because I really don't want to have to write this all out again. M to the 3rd from the top, n to the 10th on the bottom. The whole thing, we're making 4 copies of that whole thing. Do we want to really sit here and write out 4 copies of 10s? I don't want to do that. Let's see if we can reason our way through. If I were going to write out 3 copies of M, but then make 4 copies of those 3 copies, how many M's am I going to end up with? It'll be 12. 3 plus another 3 plus another 3 plus another 3. That would make us 4 copies. Yeah, that's 12. So this would be M to the 12 on the top. And on the bottom, if I wrote out 10 copies of N, we'll picture 10 N's, but I'm going to make 4 copies of those 10 N's. How many N's are there going to be altogether? 40. Oh my gosh, that's way easier than having to write them out. See if you can start finding some of these shortcuts, kind of think through them logically. I want you guys to finish the other. There's 12 there. We just did 3, so you got 9 left to go. When you're finished with that, please get my attention. I'm going to check you off. Check your answers. Let you know if you have any you need to have a look at. And then we start on the assignments. Our assignment is the first one on the page there. And then it's going to be due next class, which is 11/7. All right, I'll go ahead and put the problems back up on the board here. Sometimes it's easier to look on the screen than at your book. All right, folks, let me check you off when you are finished.